Welcome to Geology Life and Healing. In this time, we are going to talk about limonites in the porphyry copper systems in English version, dedicated to all English speaking people, my subscribers. Some of them, they're waiting for this video. Okay. So when we talk about porphyry copper mineralization, we talk about two main processes. One is primary mineralization or hypogene, or the second one is supergene mineralization or secondary enrichment. So there are two processes, but in this case, for the limonite, we are going to be focused in the supergene process, supergene environment, secondary enrichment. Okay, and as a definition, we need to make a definition for what we want to call limonite, and restricted only for the porphyry copper system that we are going to talk about. It is iron oxides, basically, or iron sulfides. So there is two types of iron, right? The iron with +2 and iron +3. So all those two makes iron oxides or makes iron sulfate. So, and something happened. It's in the supergene environment process, we have the water table. Everything we have above the water table in the supergene environment, that's what we want to call oxidation area, oxidation zone. So, but the water table drops. So as soon as the oxidation zone goes, you will have the chalcocite. But below this water table is the saturation area, right? So saturation, which one is going to saturate in minerals? It's going to develop chalcocite, limonite, cobaltite, all this area. So as soon as the water table drops, the oxidation of the chalcocite starts and starting to generate a limonite. Okay, ready? So, and there are three types of limonites. The first one is the gyrosite. As a chemical in the formula, has potassium, iron, potassium sulfate. So it's O, right? So where the source of this potassium is coming from, it has to, you need to find a bedrock that has potassium. The main one, it's granite. It has a potassium aluminum silicate. So the source of potassium is there, but the other sources, it's biotite, and Horben has also potassium. But usually in the source of potassium, it is potassium aluminum silicate, orthoclase. Okay, and the color of the gyrosite is yellow canary. Okay, and you strike the limonite, is going to be yellow canary. Okay, the second one is the goethite. Goethite is coming from the source of chalcopyrite and or bornite. So in the streak is the color is brown, dark brown, or blackish. And the streak, in the surface could be black too. And as a goethite, it's iron oxide, right? And the third one is the hematite. Hematite, it is an iron oxide, but the origin of this hematite is supergene. Okay, if we are in the supergene area, we are restricted to the supergene process only. If the hematite is coming from, in the supergene area, is from chalcocite. So the water table drops, in the oxidation process, leach the chalcocite, you have hematite in there. And so there is primary hematite in the system. Yes. And which one is that? It's, the first one is the magnetite, right? Magnetite, it's iron oxide. You add some water and everything, you take it out of the water, it's still iron oxide. right? The other source of primary primary iron oxide is specularite, right? It's metallic, loose structure and everything. You scratch, the streaks red. So those are primary. We are now going to talk about the primary. We're interested in hematite coming from chalcocite, right? Why? Because in the perfect copper systems, the main ore body, the main source of copper, it's chalcocite, 0.64% in the formula, right? The highest copper percent mineral that we have in the system. That's why it's important. Okay, and the ways that we show up in the field, in the rocks and everything, there are three ways that you're going to show up these limonites. One, you have the crystal of the limonite, and if it's in the same place that it was the sulfide, if it was the same place that it was pyrite, the same place it was bornite, the same place it was chalcocite, we call indigenous limonite. So when the limonite it moves, it develops here, and we have a little bit farther, but we know the source, we call fringing. And the third one is when we have fractures. We have limonite, we have jarosite, we can have all those jarosite, goethite in the fractures. That's what we call exotic limonite. Why this is very important? Because in order to calculate the total copper of the protolith, so the original rock, you need to know which one is indigenous limonite, because you know where is the source, right? You want to see how much pyrite was there, you need to look in for jarosite. How much chalcocite was there, you need to look in for the hematite, right? That's very important. In the very important question that I said the next video in the Spanish version, it is how you make the difference between supergenic hematite and hypergenic hematite, because you can have all this Landsat image, satellite image with a hematite, but how much is those coming from hematite? Hematite after chalcocite, and how much of those coming from the magnetite of the primary environment. So if you have a magnetite, hematite after magnetite primary, you don't have a chalcocite, blanket chalcocite area. So you need to define which one is that. So my next video, in the Spanish version I said tomorrow, but technical difficulties is coming. But in the next video, I'll show in the video how you can recognize, how you make a distinction between supergenic hematite and hypogenic hematite. Okay, and now you can see the video that I made. So you maybe one or 2 minutes, you will see the video how it looks like the limonites and the perfect copper rocks. Okay, thank you, and subscribe, share. Thank you. This is the first sample, as we can see. Orthoclase more than plagioclase. We have a granite type of rock, but something we see, this is a pyrite, and we see in places like this, what it was orthoclase, but and now it is clay. But if we have this yellow stuff, that's the jarosite, and we have pyrite in here, pyrite in there. That's what we call fringing. So that's the if everything this pyrite it was a jarosite, we call indigenous, and this is going to be fringing from this area. And we have more, right? And like in here, we have, everything is a pyrite, but we have a yellow, that's a jarosite, more jarosite. That's how it looks like. And jarosite is coming from pyrite, after pyrite, okay? This is the second sample. As we can see, this is granite, so orthoclase more than plagioclase type of rock. So as we can see, this is a vein, right? In some places like this, I hope I can see better. So you see this yellow stuff like this, that's the jarosite. So jarosite is after pyrite, right? Because it's moving from the original source, that's fringing. So this we have a pyrite in here, we have the urosite in there, so it's fringing. It's not indigenous. Okay. In some other thing we see we have a pyrite, and we have this dark gray block. It's chalcocite, and if it has areas that's bluish, it's cobalt. And moving this area, if we can see in here, I hope we can see, there's all this red area, that the hematite, but the fringing too, because the chalcocite is this one, all this block, sooty chalcocite, all this is chalcocite, and this is altering to hematite. This is fringing also, right? So in this case, the yellow one is urosite, after and from pyrite, fringing. In the chalcocite, in after chalcocite, this is the hematite. Okay, thank you. This is the third sample, as you can see it, right? This was vein. Originally it was pyrite, chalcopyrite, then pyrite, chalcopyrite, chalcocite, and at the end, as you can see in places like this, we have this dark gray block. We scratch, and as much as it's brown, it's going to be goethite. And if we find other places and scratch like this, right? We scratch, and it's going to give us reddish. That's going to be hematite. And because we saw the previous one, right? Like this one. So this was the previous one, right? So all this cobalt, chalcocite, and pyrite, it has been altered like that, and we have now like this. So everything we scratch, and it's brown or blackish. The streak is going to be goethite, and everything that the streak of is going to be reddish, is going to be hematite. Hematite coming from chalcocite, and this goethite can be pyrite too, and it can be chalcopyrite and bornite too, but mainly from bornite and chalcopyrite. Okay, thank you.